Okay, let's take a look at linear absolute value functions as piecewise functions. First, here's the overview. When you have a piecewise function that is of a linear absolute value function, so a linear absolute value function is some v-shaped function like this. Essentially, it's a line, a straight line, where we have done the absolute value to that straight line and created a v-shape, and the v-shape can be up or it can be down depending on the a value. So if you've got y equals a and then a b, x plus c plus d with absolute values around the bx plus c, this is a linear absolute value function. And it will be v-shaped upwards if a is bigger than 0, and if a is less than 0, it'll be some sort of v-shape downwards like this. And a piecewise function is simply the fact that the pieces, so let's just look at the upward function in this case, the pieces, so that red part versus this green part, those pieces have different equations. And so instead of writing this equation as y equals a absolute value bx plus c absolute value plus d, I can write it as y equals, and then I have a set of equations. In fact, I have two. The first equation is going to be the red equation, and the second equation is going to be the green equation. Now, the red equation has a particular zone, everything to the right of that point, and the green equation has a particular zone, everything to the left of that point, and that point being the vertex. And so the first thing that I like to do is I like to put in the restrictions, like what is the equation on one side and what is the equation on the other side. That goes in here, but where is this first side and second side? Those are the restrictions. They go in this part. So it goes equation, equation, restriction, restriction. So I like to take care of the restrictions first because it's easiest. The way that you take care of the restrictions is to figure out where the vertex is. In fact, you don't even need to know the vertex. You just need to know the x value of the vertex. So the vertex is at minus c over b comma d. That's the coordinate of this place. But I really only care about the minus c over b. So that's going to be my restriction. And so I'm going to change these restrictions now, and I'll do them color-coded. So in the first one that I have is the red one, and the red one is going to have x's are greater than or equal to whatever that value is, minus c over b. And then I'll do the other restriction, which is the green one, and that occurs when x is less than that same number, negative c over b. And now I need to come up with the equations. Well, the equation for the red part and the equation for the green part are similar, but they're not exactly the same. And it might be easiest to see this through an example, though essentially this is all you have to do. For the red equation is take your y equals a, b, x plus c plus d, and change those absolute value brackets to just regular brackets. And then expand and simplify this. And by expand I mean multiply this through and then simplify it. And you don't need this y equals because it's right here. So you'll get abx plus ac plus d, and it's likely these will be like terms and you'll be able to combine those together. That's what we put here. Then I go and do the same idea for the green equation. And by same idea, I mean I write down my same function that I have. I change the absolute value brackets to round brackets, and then I change the sign that's in front. I can just add a negative sign if it's a positive. If it's already negative, I change it to a positive. And then I distribute. I get negative ABX minus AC plus D, and likely these will combine together, and that'll give me my green equation, which I can put right here. And then this will be my equation written as pieces, as a red piece and as a green piece, thus known as a piecewise function. So let me walk through those steps with some numbers in here instead of just all these letters. So we're going to write y equals 2, absolute value of 3x minus 6 plus 4 as a piecewise function. So I'm going to calculate my minus c over b, and so this is my c value, so it's minus 6, and this is my b value over 3, which is 6 over 3, which is 2. And so I can set up my piecewise function, and I know x is going to be greater than or equal to 2, and x is going to be less than 2 are my zones, or my restrictions. That's where the pieces, the boundaries of the pieces. Then I need to calculate the two equations. So for one equation, for this first equation, I take 2 bracket 3x minus 6 plus 4, and I simplify it. 6x minus 12 plus 4, 6x minus 8. And that's what I put in here, 6x minus 8. For equation number 2, which will go down here, I write the same thing, except now I put a negative sign in front. And so I get negative 6x plus 12 plus 4, which is negative 6x plus 16, which is what I put here. And then I have the two v-shapes. You can see that one of the slopes is positive and one's negative, and they're straight lines, and they will meet exactly at 2. I don't need to sketch it. If you'd like to, you can and see what it looks like. That's all you have to do for piecewise functions of linear absolute value equations.